Okay, so here I want to use this question as an example to further talk about how to solve questions involving the non-annually compounded interest rate, or in this case, non-annually paid coupon. Essentially, they are the same. So let me first read the setup. This is question number 2 in quiz 4. Wine and Rolls Roses Incorporation offers a 7.0% coupon bond with semi-annual payments and a yield to maturity of 7.75%. The bonds mature in 14 years. What is the market price of a $1,000 face value bond? So um, this is actually a very conventional bond valuation question. What is a bit unconventional is this semi-annual payments. So if everything is annual, we can just work with the numbers pretty straightforwardly. But here, since the coupon is paid semi-annually, so we have to work with semi-annual numbers for each input. So that includes semi-annual coupon payment, semi-annual yield to maturity, and the number of semi-annuals in terms of the maturity. Mm, And here we don't have to worry about the face value because that's one single payment in the final date. So we just keep the $1,000 as the same. So let me copy this question in my OneNote. Okay, so back to here. Again, the trick to solve any non-annually compounded interest rate questions or non-annually paid coupon bond valuation questions is to get everything in terms of the periodic value corresponding to the frequency of the payment in this case, or in the case of the non-annually compounded interest rate, corresponding to the number of compounding periods within a year. So with that being said, back to this question, that offers a 7.0% coupon bond. So this is the annual without, as we said many times, by default, everything is always quoted annually. So this includes the coupon as well as the yield to maturity. So then we have to convert these numbers into the semi-annual numbers. So that means the semi-annual coupon payment should be 7.0% times $1,000 divided by 2. So that gives me $35. And semi-annual yield maturity should be this number, 7.75% divided by 2. So that gives me 3.875%. And the maturity should also be in terms of the semi-annuals. So that means the T, that stands for the maturity, that should be the 14 times 2, which is 28. And face value, we don't have to do anything about that. So bond value, the intrinsic value of a bond, that's the, let me use another, so VB, intrinsic value of a bond, as we said, generally equals the price if investors are rational. So price of the bond equals present value of the coupon part, because a bond cash flows include the coupon and the final par value. So present value of the par value. And for the coupon, it's a annuity, so we can plug in the formula for the annuity, which is the payment times payment, that's the coupon payment, 1 minus 1 plus the discount rate. Discount rate is the yield to maturity, and that's the semi-annual yield maturity in this case, raised to the power of negative t, and then everything divided by the yield to maturity, the discount rate. So that's the present value of the coupon part, and then the present value of the par value. That's basically the par value, and in general that's $1,000 times 1 plus, and that's one single cash flow, so we can use the present value of a single cash flow formula to figure this out. 1 plus the interest rate, the discount rate raised to the power of negative t. So now plug in the numbers. The coupon, semi-annual coupon payment is 35 times 1 minus 1 plus 3.875% raised to the power of negative 28, and then everything divided by the 3.875 percent, and then the second part, 1,000 times 1 plus 3.875% raised to the power of negative 28. So let me pull out my calculator and do this calculation. So the first part equals 591.70, and the second part equals 344.90. So hence their sum becomes 936.60 if I keep 2 decimal places. So now let's go back to the question and see which one of the choices is what we got. So it's A. Check my answer. So we got it right. So which means, again, the purpose of this recording is to further show you how to solve questions involving non-annually compounded interest rate, or in this case, non-annually paid coupon bond valuation problems. So again, the only difference compared with the annual case is now we need to get everything in terms of the periodic input. So for example, if it's a semi-annual coupon payment, then we have to get semi-annual coupon, and then number of semi-annuals, and then the semi-annual yield maturity as the discount rate. And for other payment frequencies, we can just do those kind of questions in a very similar fashion. Okay, so that's it for the recording for this question.